In this video, we're going to be looking at continuity on open and closed intervals. Now, this textbook introduces the concept of open and closed intervals much earlier in the text. So for those of you that took Math 145 with me, this will definitely be familiar because we talked about it in that class. If you haven't taken 145, you still may have run into this notion of open and closed intervals in another course, like say a pre-calculus course or algebra 2, something like that. But the idea with an open interval, if I'm thinking about, for example, let's say, let's just look at a quadratic function here. This function is defined for x values, if I'm thinking about the domain of the function, it's defined for all x values from negative infinity to infinity. But when I'm writing this in interval notation, and there's a review of this in your text in a little kind of sidebar box, in interval notation, we would put open parentheses around these endpoints. And we would do that because even though the function is defined everywhere on the real axis from negative infinity to infinity, we never actually reach those endpoint values. They're not single number values, so they are not included in the interval. And that's what an open interval is. It's when the endpoints of the interval are not included. We could have another example of a function that is not defined everywhere, but still has an open interval definition. So a function like this, for example, if I'm taking a look at this particular function, its domain is from x1 to x2, right? The x values where the function is defined are from x1 to x2. But x1 and x2, those endpoints, because they have open circles, they are not included as part of the interval. And so that is an open interval. It has endpoints that are not included, and we use the round parentheses again to signify that. Now, a closed interval, by contrast, if we had, say, one of those half circle functions, where the endpoints of the half circle are filled in. Okay, and we've got those two x values, whatever they happen to be. Well, the domain here, just like the previous function, is still x1 to x2, right? That's everywhere that the function is defined, all of the x values where it's defined. But unlike the previous function, these endpoint values are included as part of the interval because we have the closed circles there. The difference that makes in terms of the interval notation is that we use square brackets. Okay. If those were open circles, we would use parentheses. If the circles are closed, meaning that the endpoints are included as part of the interval, then we use the square brackets. And so basically, what we can use this information to do is to talk about continuity of a function on an open interval and continuity of a function on a closed interval. So if I go back, for example, to these functions, when I look at this first graph, the graph of the quadratic, its domain, negative infinity to infinity, it's an open interval. It is continuous on that interval. Because when we're looking at an open interval, the graph only needs to be continuous everywhere between the endpoints. We don't consider the endpoints, okay? Similarly, the second graph where we have these open circles at the end, it is continuous, whoops, on the open interval x1 to x2 because we're not considering the endpoints. It is continuous everywhere between those two endpoints, but as long as we define this interval as an open interval, it's continuous on that open interval. It's just not continuous if we were to call it a closed interval because it's not defined at those endpoints. When we look at this graph, the half circle with the filled in endpoints, it is continuous on the closed interval x1 to x2 because, like we discussed in the last video, when we're looking at these defined endpoints, we can simply consider the one-sided limit when evaluating whether the graph is continuous there. So open intervals and closed intervals can impact how we define the continuity of a graph. If it exists everywhere and is continuous everywhere within the open interval, then we say it's continuous on that open interval. And if the graph exists everywhere and is continuous on a closed interval, again, considering just the one-sided limits for those endpoints, then we say it's continuous on the closed interval.